From cold, silent dust to a raging ball of nuclear fire, this is the true.
It begins not with a bang, but with a whisper, a cloud of gas and dust called a nebula.
This nebula is mostly hydrogen, with traces of helium and cosmic dust grains.
Then something triggers collapse.
Gravity takes over, pulling every particle toward the center.
The cloud spins faster and flattens into a protostellar disk. At the center, a protostar is born, still cold, but growing hotter.
Matter accretes, crashing onto the surface at incredible speeds.
Violent jets of gas erupt from the poles, a stellar tantrum. Inside the protostar, pressure and temperature skyrocket. Hydrogen atoms slam together with such force that they fuse. Proton plus proton times deuterium, then helium-3, then helium-4.
Each fusion reaction releases a tiny amount of energy, but multiplied by trillions, it becomes unstoppable.
At 15 million Kelvin, fusion ignites fully. The star is now alive.
Our new star enters the main sequence, a long, stable life of burning hydrogen.
Inside, energy travels from core to surface over thousands of years.
A photon born in the core may take 100,000 years to escape. At the surface, hot plasma rises and cools in convection cells. Magnetic fields twist and snap, unleashing flares and coronal mass ejections.
Leftover dust and gas clump into asteroids, then planets. For stars like our Sun, this peaceful phase lasts 10 billion years.
Eventually, the core exhausts its hydrogen fuel.
The star swells to 100 times its original size Tunis, a red giant. Any nearby planets are scorched or swallowed.
Helium fuses into carbon and oxygen at 100 million Kelvin.
Thermal pulses cause the star to expel its outer envelope.
The expelled gas glows, creating a planetary nebula. Left behind is a white dwarf mooring, Earth-sized but incredibly dense. But for stars much heavier than our Sun, the story is far more violent.
They fuse heavier elements, neon, magnesium, silicon, in layers. Iron is the end. Fusing it consumes energy instead of releasing it. The core implodes at 70,000 kilometers per hour, a quarter of light speed. Neutrons pack together, then the shockwave blasts outward.
A supernova releases more energy in seconds than the Sun in its entire life.
In that inferno, elements heavier than iron are forged. Gold, silver, uranium.
What remains is either a neutron star or a stellar mass black hole.
The explosion seeds nearby clouds with fresh, heavy elements. And the cycle begins again. New stars born from the ashes of the old.
The carbon in your body, the oxygen you breathe, all made inside ancient stars.
Every star you see in the night sky is either being born, living, or dying.
Thanks to telescopes like JWST, we can watch star birth in stunning detail.
We've even captured jets from forming stars. Elements, exactly as we described.
The Orion Nebula is a stellar nursery, birthing thousands of stars right now.
Not every cloud becomes a star. Some become brown dwarfs, too small for fusion.
Most stars are born in pairs or clusters, not alone like our Sun.
Our Sun is a main sequence star, 4.6 billion years old, middle-aged.
In 5 billion years, it will become a red giant and then a white dwarf.
Thank you for watching this birth of a star. This is just one chapter. On Astrogen, we explore every secret of the cosmos.
If you loved this journey from dust to fire, hit like, subscribe to Astrogen, and turn on notifications. See you in the next video.